Hi everyone, this is Dr. Orkun Baycik, and today we are going to talk about payoff tables. We are going to focus on the case where we are making decisions under uncertainty. So in a decision-making process, we usually identify a set of decision alternatives to choose from based on our objectives. This objective could be to maximize our profit. Okay, so this could be one of the objectives. Let's say that we want to open a clothing store and we identified 3 candidate locations to open our store. Okay, let's say that these locations are in city A, city B, and city C. Okay, so we have 3 candidate locations, which means that we have 3 decision alternatives. Okay, after we open our store, several possible outcomes could be possible, right? So let's say that we open our store in city A, and the outcome could be that there's demand in that area for a store like ours so that we make money, or it could be that there's not enough demand and we are not making enough money, or we are losing money, right? So these are called the states of nature or outcomes. Okay, so for example, again, there is demand for a store like this, which means that the market is favorable, or there's no demand for a store like this, and that could represent that the market is unfavorable. So again, these are just examples. There could be different types of outcomes, different types of decision alternatives, but in general, we will focus on some decision alternatives to choose from and some outcomes or states of nature. Okay? So by looking at these decision alternatives and states of nature, what we are going to do is for each decision alternative and state of nature pair, we are going to calculate or estimate the profit that we could make. Okay? So that will represent our payoff. For example, if I open in city A, when the market is favorable, I may estimate that the payoff that I will have will be $10,000, for example. Okay, so that could be one example. Or I might say that when I open my store in city B, when the demand is not high or market is unfavorable, my payoff will be $2,000. Okay, so I'm going to look at all these pairs and I'm going to create a decision table or a payoff table, as we are going to see in just a little bit. Okay, so after we create this payoff table, we are going to apply a technique and select the best decision for us. Okay, and in this particular video, we are going to focus on the case where we are making decisions under uncertainty. So what this means is, in some cases, we are going to identify our decision alternatives and we are going to identify several possible outcomes for these decision alternatives, and we won't know the probabilities of these outcomes. Okay, we don't know the probability that the market is going to be favorable, we don't know the probability that the market is unfavorable, or you could say, I don't know the probability that the demand will be high for the store. Okay? So these situations are called decision making under uncertainty. After we create the payoff table, we are going to apply some techniques, and they are going to be the optimistic approach, the pessimistic approach, equally likely approach, criterion of realism, and Minimax regret approach. Okay, so we have 5 different techniques that we can apply, and we are going to see how we can use these alternatives in a numerical example in just a little bit. So to quickly summarize what these approaches mean, the optimistic approach, as the name tells, assumes that for each decision alternative, we will obtain the best possible payoff. Okay, so let's say that we have a decision alternative such as to open this clothing store in city A. We are going to assume in the optimistic approach that we are going to make the highest possible profit. Okay, In a pessimistic approach, we are focusing on the opposite of the optimistic case. So we are going to assume that for each decision alternative, we are going to make the least, the minimum amount of money. Okay, so the worst possible payoff will be obtained in a pessimistic approach. The equally likely approach assumes that the possibility or the probability of each state of nature is equal. So let's say that we have two states of nature, the demand is high and demand is low. We are going to say that the probability of the demand being high is 50%, and the probability that the demand is low is also 50%. Okay, so the probabilities are equal in an equally likely approach. The criterion of realism uses something called the weights or coefficient of optimism, and it assigns basically weights to the best case scenario and the worst case scenario, and then kind of combines them to give you some numerical values to help you make decisions. Okay, so the critical part here is that the weight that you assign to the best case scenario and the weight you assign to the worst case scenario must sum to 1. So let's say that the best case scenario's weight is 0.7. This means that the weight for the worst case scenario must be 0.3 because the sum has to be 1. And the last one is probably the most complicated one, which is the Minimax regret approach, in which we calculate something called regret, which represents the difference between the best possible payoff and the payoff from the decision that we selected for a given state of nature. So here is what I mean by that. Let's say that when the demand is high or the market is favorable, the maximum money I can make is when I open the store in city A, and that payoff is $100,000. Okay, so this is just an example. The maximum money I can make is when I open in city A and I'm making $100,000. But let's say that I decided to open in city C, which makes me $20,000. Okay, so I decided to open in city C and I'm making $20,000. So what happened is, if I chose to open in city A, I would have made $100,000. But I opened in city C, which resulted in a profit of $20,000. So the difference between $100,000 and the $20,000, which is $80,000, is called my regret. Okay? So what happened is, I could have made $80,000 more if I chose to open in city A, but I didn't, so that $80,000 is called the regret or opportunity loss. Okay, so let's get into the numerical example, and we are going to see how we can apply these techniques. So on the left-hand side, we have a table called the payoff table or the decision table, which is composed of two components, the decision alternatives and the states of nature or outcomes. Okay, so in our problem, we focus on opening a plant, but we have four options, which are opening a small plant, opening a medium-sized plant, opening a large-sized plant, and opening a very large-sized plant. All right, so we are going to select one of these, but once we make a decision, we are going to face an outcome, and the possible outcomes are the market could be good, market could be fair, and market could be poor. All right, so these are the possibilities that we can face in the future, and for each of these states of nature and for each decision alternative, we have these values that we call the payoff values. For example, if I choose to open a small plant when the market is good, my payoff will be $30,000. So I will make $30,000. If the market is fair, then I will be making 13,000. If the market is poor, I will be making 1,500, and so on. Okay, so this is how we read this payoff table. So by using these values, we are going to apply these 5 approaches that I mentioned, and we are going to see which decisions we are making. The first one is going to be the optimistic approach. All right, the first one will be the optimistic approach. In the optimistic approach, we are going to use the max function on Excel for each decision alternative to see what is the maximum amount we could make. All right, so the maximum payoff for opening a small plant is found by taking the max of these 3 values, which is equal to $30,000. I am going to repeat the same approach for each decision alternative, which means that I am going to find the best possible payoff for each decision alternative. So what I do to save time is to click on this cell, go to the bottom right, and see this plus sign and drag that cell all the way down, and everything will be calculated for you. So if you click on this, if you double click on this, you are going to see that we are taking the max of these 3 selected values. And the final step is to find the maximum of these maximum payoffs. So the optimistic approach is also called Maximax, and this is why. All right, so we first take the maximum payoff for each decision alternative, and at the end we take the maximum of these maximum values. All right, so the maximum is 60,000, and it comes from the last decision alternative, which means that based on the optimistic approach, the best decision is to open a very large plant. Okay, so this was the first approach. The pessimistic approach starts by finding the minimum payoff for each decision alternative. So we are going to look at what is the worst amount of payoff we would make for each decision alternative. So we are going to use the min function and find the minimum of these 3 values, which is 1,500. We are going to find the minimum for each decision alternative, so I can immediately go to the bottom right and drag it all the way down to find the minimum for each decision alternative. And then at the end, we are going to take the max of these minimum values. And for this reason, this method is also called the Maxi-Min approach. All right. So the maximum of these minimum amounts is 2750, which comes from the third decision, which is to open a large size plant. So as you can see, the decisions could be different depending on the approach. All right. So for the pessimistic approach, now our decision is to open a large plant. Next up is the equally likely approach. In this case, it is a fairly simple approach. All you need is to use the average function on Excel and find the average of the payoff values for each decision alternative. For example, for the first decision alternative, the average payoff is 14,833. And you are going to repeat this for all of our decision alternatives. Therefore, what I can do, I can go click on this cell, go to the bottom right, and drag it all the way down so that we can calculate the average for all decision alternatives. And then I have the averages. The last step is to take the max of these averaged values. Okay? So we are going to look at where it is coming from, and in this case, it is coming from the third decision alternative. Therefore, my decision is to open a large plant. So I just copied and pasted. And then the fourth approach is the criterion of realism. So in the criterion of realism, like I said before, we use something called a coefficient of optimism, which we denote by alpha. If alpha is high, then we are optimistic. And in this case, let's say that we select alpha to be equal to 0.8, which the question will tell you, and if you are the decision maker, you will decide how optimistic you are, okay? So the possible values are between 0 and 1, and if you are close to 1, that means you're pretty optimistic, and if you're close to 0, you are not as optimistic, all right? So in this case, let's say that we selected 0.8 to be our alpha value, and what we do is we multiply the alpha value by the maximum payoff plus 1 minus alpha, okay, so 1 minus 0.8 times the worst payoff for this decision alternative. So what I did again is alpha, which is 0.8, times the maximum payoff for the first decision alternative plus 1 minus 0.8 times the minimum payoff for this first decision alternative. Okay? So this is equal to 24,300, and what I'm going to do next is to basically repeat the same thing. 0.8 times the maximum payoff for the second decision plus 1 minus 0.8 times the worst payoff for the second decision alternative. So for these situations, what we do is to put dollar signs around the value that we will repeat. In this case, H1 will repeat. So we put H1, we put dollar signs around H1, so that when I drag this function down, it automatically calculates all the remaining values. So I click on the cell, go to the bottom right, and drag it down to calculate all of the values. And the final step is to take the maximum of these values, which is equal to 48,200. That comes from the last decision of opening very large plant. Okay, so as you can see, the decision can vary from one method to another, so therefore it is up to the decision maker to decide which one to go with depending on the situation. Okay, so the last approach that I'm going to talk about is the Minimax regret approach. So Minimax regret approach requires an additional step, which is creating an opportunity loss table or a regret table. When I say opportunity loss or regret, what I mean by that is there was a decision there that could make me, let's say, $100,000, but I chose another decision that makes me $30,000. So here's the problem. I could have made $70,000 more by selecting this other decision, but I didn't. So that 70,000 difference is my regret or my opportunity loss. Okay, so the whole idea behind this approach is to find these values. Okay, so here is the approach. First of all, for each state of nature, we are going to find the best possible payoff. So my first state of nature is the market being good, and the best payoff is found by selecting or finding the max of these 4 payoff values. And if I were to select to open a small plant, I would be making 30,000. So if I subtract the payoff from this decision from the best possible payoff, that will give me the opportunity loss or the regret amount. Okay? So that is 30,000. Let's do the same for the second decision. Again, for the good market, the best payoff is found by taking the max of these 4 payoff values and then subtract the payoff from this decision, and that regret value is $15,000. So we are going to keep repeating this for all of them. Let's say that we are doing it for the poor market and the second, or let's say we do it for the third decision. We are going to take the max of all these payoff values for the poor market minus the payoff for the third decision alternative, and that regret amount is 0, because if you look at the poor market column, we can see that the maximum payoff is 2750, and the payoff from opening a large plant is 2750. Therefore, this is my best decision under this outcome. Therefore, my opportunity loss or regret is 0, because I already selected the best possible decision for this state of nature. Okay? But instead of doing this one by one, I'm going to show you a quick tip so that you can do this even more efficiently. So what you need to do is to type your function in the first column or in the first cell here, and then put dollar signs between the letter and the number, and do it for the second one as well. So between the letter and the number, put a dollar sign, and then you're done. All you need to do is to click on that cell, drag it down, and then drag it to the right. Okay, and then you have all your opportunity loss values. All right, so let's put the border around. So I have all of the opportunity loss values. So let's look at the other 0. For example, this one, under good market outcome, the last decision has a 0 regret, which makes sense because the maximum payoff when the market is good comes from the last decision. Therefore, the opportunity loss is 0 for this decision alternative. Okay? So I created my opportunity loss table, and the next step is to find the maximum regret in each decision alternative. So we are going to find the maximum regret for each decision alternative. So remember, the method is called Minimax regret. So I am first finding the maximum regret, and I'm going to then find the minimum of these maximum regrets. That's why the method is called the Minimax regret method. Okay, so take the max of those, and since we are going to repeat this for the remaining decisions, go to the bottom right, drag it all the way down, and you have all the maximum regrets. So if you look at the last decision, the maximum regret is 8,000, which is what we have. And like I said, this method is called Minimax regret, and I have my maximum regrets here. All I need is to find the minimum of these maximum regrets, which is 7,000. Therefore, my best decision is to open a large plant. So this concludes this video. Thank you so much for watching, and I will see you in the next one.